Class, welcome to Stanford Code in Place. My name is George, and I'll be your section leader for this course. First, I'm going to spend just a minute talking about what is a section and what are you going to get out of it. Then I'm going to talk about what you have available on the web and show you around this web page and a bunch of others. And then we're going to get into the meat of this week, teaching you about Karel. So what is a section? So this is exactly how we teach things at Stanford. I used to be a Stanford student myself many years ago, and we have large lectures, and not everyone goes to lectures, or you can even watch lectures on remotely. But most everybody wants to go to the section because that's where the learning really happens. You can ask your instructors, and even though this course is free, it's like if someone gave you a free car. You wouldn't just leave that car in the garage, right? You would go out and drive it, and take advantage of it. And this course, even though it's free, you want to take advantage of it. And the section is where things really happen. So you may be watching this on recorded video this week, but I please beg of you, encourage you, if you want to get the most value out of this experience, come to section and interact with us live, okay? That is really, it's a tremendous opportunity that you rarely get. So our sections are where the learning is really going to happen, where you're going to be able to ask those questions and interact and use your skills, and don't miss section, whatever happens. So let's show you around the website. So first of all, this is the Stanford Code in Place, codeinplace.stanford.edu, and this is where all the course materials will live. So for example, here's the to-do list. You're going to watch lesson 1, lesson 2. By Friday, there'll be a lesson 3. There's an assignment to do. And also in the lessons, if you click on the number 1 or number 2, there's a lot more detailed information. And in particular, not only do they have these videos here, but I really want to encourage you, and I'm going to be walking you through some of these optional worked examples. These are small examples that are not as hard as the assignments, but they have solutions. So you can actually see how to do them. And they really are key to understanding what's going on before you attempt the assignments. So again, go into these sections, lessons here, and here's a second one here we'll take a look at later, but it has recorded videos, but then down here it's got control flow examples. So we're going to go through some of those today. The next thing I want to show you is I've included a link in my posts. Let me first bring up Ed. So over here at the right, so there's assignments here. So this is the first official assignment, Karel. This will take you to our Ed section for this particular section. I'll show you that in a second. Handouts, I'm not so really sure there's much in the way of handouts, but let's go ahead and click on Ed. So this is going to bring you to Ed. If you've ever used a course that used Piazza, Slack, or Discord, Ed is the equivalent of that. So this is where you can exchange information with your fellow students, and you can ask questions 24 hours a day, and chances are someone will be awake, especially since we have a worldwide course, and you can get some help or you can give some feedback. Remember, this is it's a volunteer effort, not only by us section leaders, but by you too. You are volunteers as well, so please help out your fellow students. You will find that there's this code in place. So this is all, 12,000 students here. So it's a pretty busy forum. Section 263 is our section, so you can find information here. You will not see these teacher ones here. This is only for me. So this has got some information in it. But remember that the real kind of the meat, you should really be looking at the Stanford website to get access to your assignments there. But Ed has some really unique features, and Ed is actually our IDE for this course, so where we're actually going to be doing our programming. So that's very different than the normal Slack, Discord, Piazza. So that's pretty exciting. You don't have to install anything. You just do it all in the browser there. So we'll show you more in a minute. So I've also created this cheat sheet for everybody, and you can find this cheat sheet, a link to it in the section posts here. And so this cheat sheet, as I go through the week's materials and I find, hey, this is a really interesting website I'm going to be referring to, I've added those websites here. So for example, there's this really cool cheat sheet, not this cheat sheet, but a cheat sheet for Karel that I found right here, and I'll just switch over to that for a second. This reference is going to be your best friend as you get to the more to the fancier function that we're going to be working on this week. So I've got this list of resources, but I've also got a suggestion on specific tabs I'd like you to open during this section. So please do go and open these 4 tabs. I've got the Karel cheat sheet, which I showed you. I've got lesson 1 worked problems. That's these here. I've got lesson 2 worked problems, which is here. And then I've got the problem that is supposed to be solved by us in section, which is called hospital. So I've got those open in tabs here. This is the lesson 1, this is for lesson 2, and this is for the hospital building. So please open each of these tabs, and that'll help us as we go through. I also wanted to point out I found this fantastic week 1 lecture recap written by somebody, and it's a really, just the Cliff Notes version of week 1, lesson 1, and lesson 2. And if you didn't have time to watch the whole video series, this is a great way to just get the information that you need. So I'm going to go ahead and close that. So let's go ahead and start looking at some of these lessons. So hopefully you've watched the lectures and you've seen some stuff, but even if you haven't, I'm just going to go through the material that was in the lectures quickly, and that will give you a really, really good primer. But you know what? Let me first show you. Let's go straight to we'll go to the punchline here. So this problem right here, hospital building Karel, and let me see if I can shrink the size. Sorry, the text is going to get a little bit small. You'll have to see the text in your own browser, but this way I can kind of show more information. So this is the problem that they want us to solve this week. And I'm just going to show you what's involved in this problem. And then as we go through the problems, you can start to see, oh, you know what? I might be able to use that when I'm trying to do the hospital, okay? Because, again, I'm trying to give you stepping stones along the way. So what Karel is going to do, this is Karel, our robot, and we want to have Karel walk down this grid here. He's going to walk down here. He's going to find one of these little blocks, and he's going to build a hospital. And let me see if I've got free. The hospital looks like this. It's a block of 6, and in the end, he wants to have a hospital built for everywhere there was a block. So you see it's in columns 3 and 4. So let's go back to the original one. So we're going to start here, and we're going to build a 2x3 hospital here. Then Karel's going to walk down, and he's going to find the next block here, and he's going to build another 2x3 hospital here. And he's going to walk down to the next one, and he's going to build another 2x3 hospital. And then he needs to stop. These are the skills that we're going to need to build this week in order to be able to do this problem. So that just sets up the problem, what we have to do. So now let's start building those skills. So the first skill is just how do you move around in Karel? So this is in Ed, and as I mentioned, we are using Ed as our integrated development environment, which is the place that we would run code. Other examples of other integrated development environments might be Visual Studio or Eclipse or PyCharm. You may have heard of some of these. If you're new to programming, it's just the place where developers go to actually write and run their code. So Ed is going to be our IDE, and so the good news is that they give you the file all set up. Okay, you really don't need to know what this means, and you don't need to know what this down here means. Just ignore it. Just pretend it doesn't even exist. All that you need to pay attention to is what happens in this function, def main. And I won't go into details as to what all that's about. The lectures give some really good information about that. Instead, we're just going to focus on how do we actually make this work. So what I'm going to do is we're going to start by writing what I call pseudocode. Pseudocode is just comments in English telling us what we think we're going to do. And then we're going to go back and we're going to replace that pseudocode with real code. So the problem here is that Karel starts out in this exact laid out world, and we need to pick up this little square here, it's called a beeper, and move it to the top of the world. So we're going to pick this guy up, we're going to go up, up, we're going to drop the beeper here, and then we're going to end up over here. So you can move Karel with some very simple commands. So for example, I can just say move, and let me try to run this. You see Karel go from one to the other. I'll hit reset again and run it again. So that's as simple as it needs to be. Let me also show you we can turn. And whenever we call a function, that's what I'm calling a move and turn left are functions, we put parens around it, okay? So let's go ahead and reset and let's try running that. So what do you think is going to happen? It's going to move, and then he's going to turn left. So he's actually going to be facing upward. And let me slow that down. We can choose here. You click on this, and you can choose how fast or slow you want to make him run. And you can actually see the steps highlighted. Do you see that? Move and then turn left. So we actually are at the right place, because what we wanted to do, so I got away from myself. Let's go back to pseudocode. What we want to do is we want to walk over to the beeper. Then what we want to do, and so comments are always, you just put hashtag, and then you can put your comment. It's a single line comment. Up here, you can do multi-line comments with either a single or a double quote to start and end a multi-line comment. So we're going to walk over to the beeper. Then we need to pick up the beeper. Then we need to walk to the top. And then we need to put the beeper. And then we need to walk to the right. So I've already done the first part, walking over to the beeper. So what we're going to do is we're going to move, and then we're going to turn left. Now he faces up. Next step, how do we pick up the beeper? So there is a series of functions on this Karel cheat sheet, and we've got several things about beepers here. So we can tell whether there's a beeper present or not. We can see beepers in the bag. I wouldn't worry too much about that. But one of the basic commands is put beeper and pick beeper. So we're going to use one of these, and well, we're going to use both of them. So first thing we need, we're going to pick up the beeper. So that was pick beeper. And let's just try running that. And I really do encourage you to, especially as you're getting started, to run everything. Okay, so he turned and he picked up that beeper. Now let's walk to the top. So what can I do? I can do move, 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 and let's just throw a fourth one in here. And let's try running that. So, and watch here as the lines are highlighted. Move, turn left, pick up the beeper, move, move, move. Ah, you see this red? What does this red mean? Well, this red with the exclamation point tells you, and you see as I got highlighted over that exclamation point, it actually says front is blocked. So if I was here, I can move once, I can move twice, but I can't move a third time or a fourth time. So that's how we can debug it. And also, so stepping it through at 1x is a great way to debug things. And I'll show you that you can actually, let's go take a couple of steps, you can actually pause it. And now, watch, I can actually step through it. Pick up the beeper, move, move, boom. There's my error. So that's how you debug in Ed. So let's get rid of these two lines here. Now we need to put the beeper. So we had a pick beeper and we have a put beeper, I think. And let's just quickly check over here. Put beeper, there it is. That cheat sheet is going to be your best friend. So let's put the beeper. Now we need to, well, let's just go ahead and run it, right? Let's run it. In fact, I'll show you that you can run it much faster, right? Because now I know what I'm doing. Boom. Okay. Put the beeper. Now we need to walk to the right. So now what we need to do is turn to the right. But let's take a look here. There's a turn left, but there's no turn right. And quite honestly, there's no good reason why there isn't, other than they wanted to teach you how to do turn to the right. So what I'm going to do is I'm going to say turn right, because that's what I want. But I need to actually write this function myself. So let's go and do that. So when you write a function, you just say def, and then the name of the function. And then you always have to put a colon after the function, and any command, any multi-line command, you need to put a colon there pretty much. So what does a turn right consist of? Well, turning right is the same as if you turned left, left, and left. So let's try that. Let's do a turn left. I'm going to copy this line. And, oops. Let's see if I can do that. There we go. Turn left, turn left. So 3 lefts. And I'm going to put a comment here. So turn right by turning. Actually, I don't like putting the implementation in the function. You should just say what it's going to do. So we're going to turn right. And then we need to walk 1 to the right. So let's do a move. Okay, let's go ahead and reset and run this. So I'll let it run at full speed, and you can see that that works. Okay, so if you have a problem, you can almost pause it and step through it. And then the last thing I want to show you is that there's a submit button down here, and it will tell you if it passed, but to be honest, in these worked examples, it doesn't really check anything. So don't get too excited if it says passed. In fact, here, let's do something that we know is wrong. Let's see if it catches it. I don't think it will. See, it passed. So, but what I'm going to tell you is that get used to doing that, because two things. Number one, it tells me that you submitted the problem so that you've done it. Otherwise, I don't actually know you've done it at all. Okay, so just even if you attempted, just go ahead and hit submit so that I know you did it. And then the second reason is because when you get to the actual assignment, the submit actually does run tests. Okay, so that's move beeper. I almost forgot. There's one other thing I want to show you here, and that is that actually I'm not 100% sure what you see. So I can see submissions. You guys can't see submissions, but you can also look at the solution. I believe you should be able to see this. So if you can't figure it out, I beg of you, don't just go and look at the solution. I want to explain something to you. So I've been teaching for many years, and I've helped a lot of students learn. I figured out why students don't learn. Number one reason students don't learn is because they cheat. They look at the solutions. And these days with the internet, there's no problem out there that doesn't have a solution on the internet. Don't do it, okay? Because I can guarantee you, if you are doing that, you are not going to learn, okay? It is better to have the struggle. I tell students, your job is to make mistakes. Every single day, you need to be programming and making mistakes. Throughout a week, you need to be making at least 50 mistakes. If you aren't making 50 mistakes, you aren't learning. So please do the code on your own. When you can't figure it out, then go take a look at the solution, okay? But you must try first if you want to learn. Okay, so here's a solution. Well, this is for Archway. Let's look at move beeper. That's the one we were just trying. So here they do find a beeper, pick a beeper, move to drop location, put a beeper. So they did some more decomposition, but I wasn't trying to work too much on decomposition in the first problem. So anyways, there are solutions. Let's go back to the challenge. So the next thing I want to do is show you Archway. And I've already left a couple of functions in here. So I left turn right, and I have another one in here called move 3 that's going to be our helper. And what we have to do here is we want to move this we want to jump over this archway. So Karel has to go up, 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 right, 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 down, down, down. And you notice that I had to move three times in each direction. That's why I have a move 3 function defined. So let's do some pseudocode. What do we have to do? I just said it, right? So move up 3, move right 3, move down 3. Okay, so how do I move up 3? So right now I'm facing to the right, and I need to face up, okay? Because there's no move up, there's only move, whichever direction Karel is pointing. So we need to turn to the left to point up. So we're going to turn left. And let's, like I keep on saying, let's just go ahead and run it, see what happens. There we go. That's what we want to do. Now we want to move up 3. So let's call move 3. And actually, you know what? Stanford Code in Place wants us to use what they call snake case, where you have to put an underscore between everything. It's not my favorite, but it's apparently a Python standard. So I'm really a Java guy, so you'll find I make a lot of errors because Java and Python are syntactically similar at a high level, but grammatically they're very different. Okay, so let's go ahead and run this. So it's going to turn left and move up 3. So hey, it worked. Okay, now we need to move right 3. So which way do we need to turn? Well, we need to turn right to point out this way. So that's why I left in the turn right. So let's try that. So now he comes up 3 and he turns to the right. Do you see how he had to spin himself around? So we turn right, and then we need to move 3 again. And sure, why not? Let's go ahead and run that. And then the next thing we need to do is to move down 3. So let's verify that works. And you notice again how the highlights are going over here. Okay, so now we need to move down 3. So it's exact same process as we had before. We need to turn right. and then we need to move 3 again. And now one last detail is that notice how he's facing to the right, and yeah, it says right here, Karel ends up on the right side facing east, okay? So always look at the problem description because it does matter sometimes. So after we get down, which way are we pointed? Let's go ahead and run it. You should try to figure out which way is he going to be pointing. Well, he's pointing down. We need it to be to the right. So that would be turning left. So we're going to do one last turn left. And I'm going to throw in a comment here. Need to face left at the end. Let's try running that. Oh, forgot the parens. That's one of my 50 mistakes for the week. Okay, so he's going to move to the right, he's going to move to the bottom, and then he's going to face to the right. So good, it works. I would click submit, but of course it's not really going to do anything. Okay, so that is an example of how you can like move around a structure. You're going to find that that comes in handy as well later on. So those two examples are from the first lesson, which is just how to move around, how to pick up beepers. And I do encourage you to go through all of these. By the way, Rainbow requires stuff that isn't. It's actually in chapter like 9 of the text, which you can find on the Stanford Code and Place website. So you can look at that on your own, but don't be surprised if you have some difficulties on that. Okay, so let's go to the next set of problems. So these are problems from lesson 2, control flow. So the first one is called move to wall. And you know, it's funny, this thing doesn't like to update here. Hold on a second, let me fix that for you. Okay, well that took far too long. Unfortunately, Ed is a bit buggy. What was happening was down here, this what they call world was it was from a different problem. And what I did to solve it was I ended up having to close all the other Ed tabs and then reload from scratch. And that seemed to fix it. So what you should be seeing is a world like this. So move to wall. What we're supposed to do is just move Karel forward until you hit a wall here. So what this is going to do is teach us about loops. Okay, so in this case, we don't. In this particular example, well, there's a couple of ways we could do it. I mean, let's go ahead and use the indefinite. So let's assume we don't know how many walls are here. Oh, it looks like I can actually remove the wall. That's cool. So let's assume we don't know how many steps we can go before we want to hit a wall. So there's a function for that called a while loop. And here you can see that it's defined like while condition code to repeat. And we're looking to see if we can hit a wall. So we have several different conditions here, and front is clear. It's not 100% clear what the name means, but what it means is it's looking for walls in front of Karel. So we're going to use the combination of those two, while and front is clear. So let's go back to the code. And so what we're going to do is we're going to write a while loop. So the format is while, and then the condition, there's no parentheses in Python. So the condition is front is clear. While front is clear, we want to move. And notice how I, Java guy, I'm always forgetting to put that out there. So you always put the colon there. And notice how I indented in. So in Python, the indent is how it figures out what is in a code block. So in languages like Java, we have squiggly braces, but we don't here. So instead, we just use indents. So this is what it's gonna do is while the front is clear, it's gonna move forward. And let's run it at just 1x here, so you can really see what it's doing. So while the front is clear, it's moving. While the front is clear, it's moving. Oh, it's done. What happens if I take out this one, and this one? Let's see if that works. Oh no, it reset. There, let's see if I can reset and then take out the walls and then run it. Okay, while front is clear, move. While front is clear, move. While front is clear, move. Yep, so it's going to keep on walking all the way until it hits the wall. And let's go ahead and put a wall back in the middle here. Oh, sorry, reset first. Then let's put a wall back here. Let's run it at 4 times, a little bit faster. So, boom, 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 and we're done. Okay, so now we know how to walk until we find a wall. Let's see, is there anything else I could do here? No? Okay, I can't drop any beepers. So let's go and take a look at another example. So this one is called 4 in a row. Oh, darn, it did that problem again. Let me reset everything, get the right world. Okay, well that time my old trick didn't work. What I had to do is I had to close out the tabs and then actually loaded the lesson 1 worked problems, then came back to lesson 2 worked problems, and that solved it. I really hope you guys don't run into this problem. I actually wasn't running into this problem earlier today, so I don't know if it's what's going on. So what we're supposed to do is put 4 in a row, and unfortunately these directions are completely wrong. It's basically telling you to go up a column, but you're really supposed to go right. And also, they made it a 3x3 instead of a 4x4. I don't know why. Let's go ahead and just fix this. It's a good example to show you how you can modify the world. So what we want to do is we want to put 4 beepers down in a row. So we know exactly how many beepers we're going to do. So in this case, so in the previous case, we didn't know how far we needed to go. And that's when you use on a while loop. But if you know how many you're going to do, you want to use a for loop. So let's take a look at the for loop definition. So here, for I in range, and I'll later on in the course you'll know, I'll tell you, never use I, J, K, X, Y, Z, because while it works in this simple example, in any real code, these variable names, they're going to lead to disaster, okay? You want to actually use something that tells you what's going on. But anyways, for I in range, and then you put the count there, and then you have the code to repeat. So what code are we going to repeat? Well, we're going to be putting beepers, right? So put beepers, probably what we're going to do. So we're going to do for I in range, and then the range is going to be 4, colon, and then what we're going to do is we're going to, well, first let's just try move, right? We know how to do that. Let's just see if it does that. Boom, 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 boom. Oh, we ran out. We actually hit a wall there. So it's not 4 moves, it's actually 3 moves. So that's something to think about. Let's go ahead and change that to be 3. And let's now put beeper. Okay, let's reset and run that. So now it's going to put beeper, put beeper, put beeper. And now we didn't run over because we only executed 3 moves, but we only put 3 beepers. And this is an introduction to what we call the fence post problem. And there are many different solutions you can have to solving the fence post problem. When I say fence post problem, let me bring up something. So I've got this really terribly drawn set of fence posts, which I'll label P. And then between each post, we've got wire, which I'll label W. So the most general case of a fence post problem is anytime you have n things that you want to do, that's the 4 posts, and n minus 1, in this case 3, things you want to do in between them, wires. And so the way I'm going to teach you is actually from the Java book that I teach from, and they call it the loop and a half, which is really kind of the half and full loop, which is the first thing you do is you put the first fence post, and then you do a wire and post, a wire post, and a wire and post. There are other ways where you can do a post and wire, post and wire, post and wire, and then you do a post at the end. Either one works, but this is the way I'm going to teach you. So the first thing we're going to do is, so as I was talking about, we're going to put that first post in the ground, which means we're going to do a put beeper. And then doing that wire and then the post means that we're actually going to reverse the orders. So we're not going to put the beeper, we're going to actually move first. So we're going to put the beeper, then we're going to do in a loop, move beeper, move beeper, move beeper. So let's reset and run that. So this solves the problem. So this is the way that I'm going to be teaching in my section. The lectures may use the other form where they put an extra put beeper at the end. Again, either one will work. But it is important to, number one, identify when you have a fence post solution. So again, sorry for the math, but it's really the easiest way I can figure out. You've got a certain number of things that you're doing at the beginning and the end. Okay, that's what I call n. And then you've got n minus 1. So you've got between each of those things, you're trying to do something. And this can span the gamut. There's so many different places where you have this fence post type solution when you're printing things and when you're calculating things. It happens all over and over and over again. So it's so important to realize that that's happening so that you can remember, oh, okay, fence post. That means the loop and a half. So I'm going to put that first half loop there and then the full loop. So that's important. All right. So that's pretty much this problem here, 4 in a row. So what did we learn? We learned how to use for loops, and we learned how to solve the fence post. Okay, so now I'm going to get to a more sophisticated problem. They call this Spring Flowers Milestone 2B. Climb the stem with while loops. So what's going to happen here is we've got Karel here. Karel is going to be put in front of this stem, and what we have to do is crawl up the stem. And so let's start with pseudocode and think about what kind of pseudocode we need. So what are the steps? So we need to crawl up the stem, right? So let's just say we're going to crawl up the stem. And that's actually where we're going to end. I'm going to actually take this problem farther, but let's just start with that, crawling up the stem. What is involved in crawling up the stem? So pseudocode is not just one definition. You start and then you refine it. So crawling up the stem, what does crawling up the stem mean? Well, first we're going to have to actually turn up, which is actually going to be left. So we're going to need to turn up, and then crawling up the stem, what we're going to be doing is how are we going to figure out how far to crawl up the stem? So we're going to have to do while something move, right? And so notice you can see here that he's pointing upward. And so we're just going to be facing upward the whole time. We're going to move. Now, ideally, what we want to see is whether there's a wall next to us. Let's take a look at the Karel reader. This is a little bit confusing. So front is clear, always looks at the direction you're pointing. So when Karel's pointing up, it's what's above him. But they also have this left is clear and right is clear. And what's not clear is that what that means is that regardless of which way Karel is pointing, you want to check the left and the right. So what we can do is check if right is clear. If right is clear, then we know that we want to move up. So while, I'll just put right clear, move. And then when we're at the top of the stem, we're done pretty much. So let's try writing that code. Now, turn up left. So we're going to turn left. Then while, and then let's quickly switch over. What did that say? It was while left is clear and right is clear. So we want right is clear. So while right is clear, colon, then what we're going to do is move. So let's go ahead and try that running. Let's go and switch it to 1. And I'll actually pause, and we'll do the step this time. Okay, so we turned left. He's pointing up now. And while right is clear, move. What is it doing? That's funny. I'm not sure what it's doing. Okay, let's try it running it. Does that help any? No? Right. What happens is it's done. So I said, I put in, and this is, it's bug number 2 of my 50. So there's right is clear, and then right is blocked. What we actually want is right is blocked. Okay, so not clear. And so that was a great example of debugging. It's like, why isn't it doing anything? Because right is blocked is what we want. Okay, let's try running that. Pause and we'll step. Okay, so he turns left. While right is blocked, move. While right is blocked, move. While right is blocked, move, move. And now the last time, it's going to check right is blocked, and it's no longer blocked. So it's not going to execute this move, and it'll actually end. And that's exactly where we want to leave it. But I'm not going to stop there. I'm going to take you guys further, because you may have seen in the lecture that there's this steeplechase thing. Well, we're halfway to the steeplechase. You go up, then you go up, and then you want to go right, and then you want to go back down. So let's figure out if we can build the steeplechase ourselves. So what we want to do now is we want to get ourselves over this hump, and let's actually put this into a function. I'll get into decomposition. So what we've done here, let's call a function. This is climb up stem. That's what this function is. So let's put in main. We're going to climb up stem. Then, that's my Java side showing. Then we need to, well, what should we say, walk over stem. And then we want to climb down stem. All right. So I'm also going to introduce the pre and post conditions, which are in the lecture. And this is a really great concept. It's actually kind of an advanced concept that I don't teach in my classes because it's a little bit advanced. But Stanford wants me to teach it, so we're going to teach it. So what we want to define what is true before and after. So before, we are facing right. And on let's say pre, that's so pre-condition. And then a post condition at bottom of stem. And then when we're done, post, now which way direction face? We're facing up, above stem. Okay, so now we're going to do walk over stem. So let's go ahead and define that function. Def, and I'm just going to copy this up here. So walk over stem. Before we even write it, let's define what the pre and post are going to be. So the precondition is that we are now should be facing up and above the stem. And the post conditions, we should be facing right and above and right of stem. And the pseudocode for this is we're going to need to turn right and then walk. And that's pretty much it. So let's turn right. And I'll grab that code in just a second. And then we're going to walk. So we just have to move one step. Let me grab that code. Okay, so we've got turn right and put down here and then move. So let's just go ahead. We've already done this and this. Now this last one isn't defined yet. So just so we don't throw an error, I'm going to do a def climb down. Now actually here, let's do it. Let's just comment that one out. Let's just put a comment there and get rid of that. Okay, let's go ahead and set this to be 4 and let's run. So he walks up, he turns right, and then he steps over. Okay, now the next thing is we need to climb down the stem. So let's go ahead and remove that comment. So we're going to define so the pre is, again, grabbing this here. That's we're facing right to the right and bottom of stem. Post, we're going to be facing down and bottom of stem. So how are we going to climb down the stem? Well, we first need to turn ourselves. And then we need to you know, I'm thinking the reason I paused is because a lot of the code that we did for climb up stem is the same. Well, it's just these couple of lines of code, so I won't write a function for this here. I'll just copy this here. Slightly different though. Walk down stem. So as I was saying, this code is almost the same, but not quite. What's different? Well, and previously we were looking whether right is blocked. Guess what? Now we need to check if the left is blocked. And to turn down, which direction do we have to turn him? He's facing to the right. We need to go down, so that's a turn right. So let's try running that. So he walks up, he walks over, and then he walks down. Oh, we never called it. Is that a problem? Climb down stem. While left is blocked. Oh, okay, yeah. So here, the reason he didn't do anything is because the left isn't blocked. All right. So what we actually need to do is we need to, I want to take advantage of this code. So what let's do is after we turn right, we'll just go ahead and do a move. That'll put us on the right track to be able to use this code. And it's just another example of how debugging works. So while left is blocked, now I'm really curious. Okay, let's go ahead and run it. And I'm going to pause it when I get up here. So let's step. Okay, so we're going to turn right. Now we're going to turn right again. Now we're going to move while left is blocked. Oh, left is not blocked. So I'm not exactly sure what's wrong with left is blocked. I think it must not be how I understand it. But there's another function we can use. We're now pointing down. And what we're really trying to do is look for this wall down here, not this thing, the divider. So actually what we're going to do is we're going to use the front is clear. Let's try running that. We go up, we go over, and then we go down. Okay, and I would leave it to you to continue this on and figure out how you can take this whole section that we did right here as a hurdle and make that into a function, and then step over to the next one and do that hurdle. Okay, so that's an exercise for yourself. Okay, so finally we get to the meat of this class, which is how do we build this hospital? Well, let's start writing some pseudocode. And we've already seen several of the most important parts of this. So what we need to do is we need to walk until we hit a beeper. Then we need to build hospital. And then we need to repeat somehow. And I'll just put, for now, let's just say repeat. Let's try to hit the first one, build the hospital, and then we'll figure out what to do after that. So how do we walk until we hit a beeper? Well, we don't know where the beeper is, so we need to use a while loop. And we know how to put beeper, and we know how to, we haven't used actually the beepers present. That's how you tell if there's a beeper there or no beepers present. So that's what we're going to use, beepers present. So we're going to do while and then no beepers present. So while there's no beepers present, we're going to move. And let's just see if that works. Run. Okay, so as soon as it hit a beeper, we're done. Great. Now we have to build a hospital. So how do you build a hospital? Well, how about you call build hospital? And that's only slightly a joke because now we have to define a function ourselves to build a hospital. And we've already done the steeplechase and things like that. So we already kind of know how to move around and do stuff. So what we're going to have to do to build a hospital is we are going to want to, let's build it in 2 columns, right? So we'll build first column up, move to next column, build second column down. Let's go ahead and work on, so building a column is always going to be 3. So what we can do is we can actually, it's not really worth making a whole function to build it and build it again. We'll just write out the code a second time. So building the first column up, so first thing we need to do is turn which direction? We need to face up, so we need to turn left. So turn left. And hold on a second, I'm going to grab later we're going to need the turn right, so I grab the turn right. But for now, we're going to turn left, and then we're going to, we know how many we're going to do, right? So we don't want a while loop, we want a for loop. And we want to build 1, 2, 3, right? So let's go for I in range 3. And we're going to put beeper, and then move. Okay, let's see what happens now. So it's going to walk over. Oh, run. It's going to walk over like we did before. Oh, sorry, I got some errors. Almost forget to put that in there, and put that in there. Okay, there we go. Turn right. 1, 2, 3. So we did actually put only 3 beepers in. Excuse me. But now we're 1 too high. Well, this is not the end of the world. Let's move to the next column. So we can actually still make this work. We can just turn right. And then move. And then turn right again. So now we'll be facing down. And then building the second column down is actually basically the same thing, right? Let's try that. Let's reset and run. So he moves up, builds 1, builds 2, builds 3, moves over, builds 1, builds 2, builds 3. Okay, so not quite so good, right? So what was the problem? Well, we put a beeper here, and we should have really moved. So let's go ahead and do that. We're going to move down 1. So now it's going to build those 3, right? So let's just try and run that. Some of you may have already noticed what the problem was going to be. One, 2, 3. Oop! Front is blocked. So this was this is the fence post problem here. So we did a move up here, but what we really want to do now, so we moved here. We want to put the beeper, move, put the beeper, move, put the beeper, but we don't want to do that last move. So there's a couple different solutions we could do here. We can move and put the beeper in here. And we can get rid of this guy right here. Let's try that. Let's see if that works. Run. And other solutions won't require to actually go 1 too many. I mean, it would be easy to fix that. I'm just not going to bother. Okay, so we actually did build a hospital. And notice that the building of the hospital, this is starting to get important. The preconditions and the postconditions. Let's start with the post since we're looking at the post. The post is facing down. And that's actually not the greatest thing because we really want to be facing right. So why don't we fix that? We'll make it facing right, and we'll throw in the last turn right. So now we're going to be facing right at the bottom of the second call. The pre was facing right at the 1, 2, 3, yeah, bottom of left call. Let's say right call. And it's important to get these things down because we are going to need to do this again later, right? So we want to make sure that we set ourselves up for success. Okay, so we've done it once. Now I mentioned that we were going to figure out how to repeat, right? So let's think here. So we don't know how many of these things there are. So we don't want a for loop. We want a while loop, right? So we've already got a while loop out here. While no beepers present, move. And we could put that into a function to like basically find next beeper. Well, we could leave it as well. So if we put a while loop outside of this, what would it be? Let's think about that. So remember when we did the problem where we were trying to find the rightmost wall? So we could do that again. We can just put this in a loop, and loop until we hit right wall. So while front is clear, you remember we did that. Now we're going to indent all of this, and I'm really hoping that this, Oh, good. So I just moved all that over. So while front is clear, let's see what happens here. I'm going to speed it up to 10x. Oh, there's a, I'm always forgetting. You will always see me forgetting this because it's just not something we have to do in Java. Okay, so we're going to build that hospital. Oh, okay, see the problem is he's facing down. It should have been facing right. So why did it face right? Build hospital. Let's go ahead and run it. And I'm going to pause it when we get to the end. Okay, so let's step. Where are we now? So we're building, so we've just finished that. He's facing down. Oh, yes, I did a turn right and it needs a turn left. Turn left. Okay, so let's stop and let's rerun this. Turn left. There we go. Oops, we have too many. Okay, let's stop him. So we're facing the right way, but then what happened? He should have then done the no beep. He should have been moving. So let's go ahead and debug this again. Let's get it down there. Stop. Okay, so let's step. Where are we? So he's facing the correct direction. While front is clear. That's good. While no beeper's present. That's good. Oh, it's because we're sitting on a beeper. Okay, so when we finish building the hospital, we need to move. And actually, we need to really put a check here. If front is clear, do a move. That will set us up to be over here. Then it should allow us to repeat. And if I had taken this and put it into a function, I probably would have seen that because I would have had a pre and post condition, and I would have seen that I needed the precondition to be that it's facing the right direction and it's not sitting on a beeper. So far, so good. Woohoo! Okay, great. So our time is up for the hour, and I hope that by walking you through first, how do you move around? How do you set and pick beepers? Then looking at the flow control. How do you do a for loop? How do you do a while loop? And then finally, and doing the steeplechase. Then finally coming here, hopefully this problem wasn't so hard. So what I recommend doing is do some more of these worked examples. I do find that these really will be useful to you and prepare you. I know most of you just going to try to jump to the real meat of the assignment. You're welcome to try that as long as it works. But if you have troubles doing that, then I would definitely have you go back and take a look at these samples. Here's the assignment problems that you're going to be working on. So that's going to be your assignment, but that's not due till like, I don't know, 28th or something. It's a long ways off. So don't rush through it. Enjoy it, okay? And please, next week, come in person for an exciting and interactive session in our section. Thank you very much.